Hey there, you guys. Well, it's been a full week of this distance learning. Wonder how everything's going for you guys. I wanted to let you know that you probably saw in the grade book that I got all of those quizzes graded and recorded. Um, Everything was up to date. There was a couple places where I was able to go in and give partial credit, just kind of dependent on how the answers were presented. Overall, the grades were pretty good. It was kind of polarizing. A lot of you guys that normally do pretty well still did very well. I also noticed that those of you guys that got on that Zoom conference that we offered up last week did very well, so I think that was helpful. So I encourage you guys to take advantage of that kind of thing. We'll do another one before we take our test coming up April 3rd. But overall, you did pretty good. Some of you guys, I was a little surprised. They weren't awful at all, but I was just a little surprised that it seemed like maybe you had a couple questions, and I haven't heard from any of you guys. So I can't say it strongly enough, you guys. When you have questions, whether it's going through notes or homework or a review or anything like that, you've got to be proactive. Send me a text, send me an email, call. Um, I'm happy to try and answer questions that way, or if you even need to just get together individually on one of these video conferencing kind of things, I think in just a short amount of time I can really help y'all a lot. So you guys know that I'm always willing to help. I wanted to kind of point out the calendar. I've showed this to you before, but I just wanted you to kind of see where we are for the next couple weeks. So here we are today. We're going to be doing section 8.5. We'll do the notes. You need to have those completed by the end of the day today, and then you'll do the section 8.5 homework, which will be due by your class time on Thursday, like we normally do. Um, Also, I wanted you to kind of keep in mind we have this quiz over section 8.5 on Thursday. This section is a pretty big, important one as far as um, some of the solving skills that you're going to learn. It's also an ACT, SAT type concept. So, lucky for a lot of you guys, I don't know if it's lucky or not, um, those are canceled, I believe, for this year, but you're definitely going to want to be prepared for this come next year. But it's just going to be, that quiz is going to be really short, almost kind of like do a couple homework problems, kind of short, very nothing, and and then we'll also go over the notes for section 8.6. And so then we have next week we have 8.7, but then keep in mind, come Friday the 3rd, we'll take a test over Unit 8. And when I say Unit 8, I mean all of 8.1 through 8.7, right? We've already taken this big quiz, 8.1, 8.4, so it'll be all of that plus this new stuff that we're learning here in these 2 weeks. Okay, um, so as you guys may or may not know, all of this Corona stuff has kind of created havoc everywhere. I don't know if you guys have tried to go to the store. I kind of was making fun of everybody who was panicking and hoarding up everything. And then I went to the store and I realized there was nothing left. Nothing. You may have heard people talk about a couple weeks ago. Everybody was going crazy trying to buy up toilet paper, thinking we were going to have some shortage. And I made fun of all of those people. And so now I went to the store and there is no toilet paper. Well, maybe I'll keep you guys up to date. We are down to our last 3 rolls of toilet paper. So this is how I feel, kind of going to Costco, Walmart, any of those kinds of things, and trying to be funny. I sent this to, I think I was talking to Mrs. Morris on an email. I sent this to her, and as you might know, if you know her very well at all, she can't let it go. This is the one she replied with, and I have to say, she kind of won that one. So I'll let you appreciate that. Okay. If you're not laughing right now, I'm sure it's one of those kind of things where you had to be there. If we were actually in class and this were live, you'd probably be rolling on the floor. All right, so let's talk notes. Let's talk section 8.5 notes. So solving exponential equations. Here's the thing. When we're solving exponential equations, there's going to be two types. Two types of equations. Okay? For the first type, These are the types where we are going to try and look for the same base. All right, so first method is the type where you're going to get the same base. And I would say of the two types, you're always going to look for this one first. Okay, look for this one first. Look for this first. Okay? Um, so, the first step is, can you get the same base? So, change to same base. Obviously, if you can't change it to the same base, then you can't use this method, and then we'll talk about the next method in a minute. So I'm going to kind of lead you through example 1 while we fill in these steps. So when I look at example 1, when I look at both sides of the equation, on the left you have a base of 1/8, and on the right you have a base of 4. Now the exponent that's up here on the 4 is a 1. We don't normally write it if it's a 1, right? But the 1's the exponent, so the 4 is the base, the 1/8 is the base. So looking at those two numbers, can you rewrite those with the same base? Well, think about it this way. If it were just an 8 over here on the left side, I know that 8 is actually 2 cubed, right? 8 is 2 cubed. But if I want it to be a 1/8, wouldn't it be 2 to the negative 3? Okay, so 2 to the negative 3 is 1/8, but that 1/8 is actually being raised to the x plus 1. So what I did was I changed the left side, but I didn't change the value. I just, instead of 1/8, I wrote it as 2 to the negative 3. On the, did I say right hand side? I meant left hand side, sorry about that. On the right hand side, I have 4. Well, can I write 4 as a base of 2? Well, of course. 4 is the same as 2 squared. So I've changed to the same base. All right. Well, let's clean this up for a minute. Remember when we've done this before, whenever you raise a power to a power, don't you multiply your exponents? Like if you had x squared and then I raised it to the third, wouldn't I multiply the exponents and get x to the 6th? Right, just as far as a basic rule. Well, right here, if I raise a power to a power, I'm going to multiply my exponents. So what I actually have here is 2 to the whatever negative 3 times x plus 1 is. Well, wouldn't that be negative 3x minus 3? Sorry, negative 3x minus 3. Okay, and then again on the right hand side I just have 2 squared. Alright, so now that I have the same base on both sides, the next step is to set exponents equal to each other. Set exponents equal to each other. And I hope that kind of makes sense to you. Think about it. If these numbers are the same, then the only way, since this is an equal sign between them, the only way they can be equal is if this is the same. Well, that's what we're going to do. We're going to set our exponents equal to each other. So negative 3x minus 3 has to equal 2. Okay, well now I have a nice, neat basic equation I can solve for x, right? So add 3 and then divide by negative 3, and x equals negative 5/3. Okay? So, let's try that on example 2. When I look at this, I see on the left-hand side the base is 27. On the right-hand side the base is 1/9. So can I rewrite those with the same base? Well, I think so. 27 could be a base of 3. I could write 27 as 3 cubed. And isn't that 27 being raised to the x minus 4? On the right side, 1/9. Well, if it were a 9, it would just be 3 squared. But in order for that 9 to be in the denominator, it needs to be 3 to the negative 2. So 3 to the negative 2 is 1/9. And that 1/9 is being raised to the 2x plus 1. Okay, so let's clean it up. Remember how we talked about when you raise a base, when you raise an exponent to another exponent, you multiply them. So on the left, I'm going to have 3 to the 3x minus 12. On the right-hand side, when I multiply my exponents, I'm going to have 3 to the negative 4x minus 2. Now that I have the same base, the 3's are the same base, that means I can set my exponents equal to each other. So that means 3x minus 12 has to equal negative 4x minus 2. Great. Now I have a basic equation I can solve, right? Get your x's on the same side. So I'll add my 4x, and that's going to be 7x. And I'll add my 12 to the right side, and that's going to be what? 10? Check my math. And so x equals 10 over 7. So same base, and that way you can set your exponents equal to each other, because you can't set your exponents equal if you don't have the same base. All right, now example 3, it looks a little more involved at first when you see the fractions. So we're trying to think about 3/4 and 16/9. Well, 3/4 is kind of as small as it goes. Does 16/9 relate to the 3/4 at all? I mean, it seems like it's upside down, doesn't it? What would be the same base on this one? Well, how about we leave the left-hand side as a base of 3/4? So I've got 3/4 to the x plus 2. But on the right-hand side, think about it. The 16 is a 4 squared, and the 9 is a 3 squared. But I don't want the 4 on top, right? I want the 4 on bottom. So what if I did this? What if I wrote it as 3/4? But then, okay, so I know it has to be squared in order to get the 9 and the 16. But because I want them to flip, what if I put a -2? So wouldn't that square the 3 and move it to the bottom? And wouldn't that square the 4 and move it to the top, which would be the 16/9? Okay, I hope you can see that. So that's going to give me the 16/9, and then that whole thing is being raised to the 3 minus x. Okay, let's clean it up. So I still have 3/4 to the x plus 2 on the left. Excuse me, but on the right, I've got 3/4. And if I multiply my exponents, what is that? -6 plus 2x. So again, do you see I have 3/4 as the base on both sides? So that means this exponent has to equal this exponent. So x plus 2 has to equal -6 plus 2x. Right? So again, when we solve, we get our x's to the same side. Not that it matters, but I think I would move my x to the right side, because then I would be subtracting it, and that would leave me with a positive x, which means I would want to move the -6 over to this side, so I'd add 6 and I would get 8. So x equals 8. All right, so if you can get the same base, you definitely want to do that. Now, the other method, I mean, think about it. If this method was getting the same base, then this method is what if you can't get the same base? So we're going to say here, cannot, whoops, I might even spell it right, cannot get same base. Okay, if you cannot get the same base, well then we have to go through these steps. Okay, so if we cannot get the same base, then we are going to have to use logarithms. Use logarithms. Okay, so the first step is going to be to isolate the exponential term. Isolate the exponential term. So why don't I go ahead and I'll write down all the steps, and then I'll kind of lead you through each of those steps. All right, so let's talk about the next. All right, once you've gotten the exponential term by itself, then what you're going to do is take the log of both sides. Take Now, you can take any log. You could take log base 2 of both sides. You could take log base 5 of both sides. You could take log base 10, natural log, and any of them work. And your answers won't look the same, but they will be equivalent. And different teachers teach it different ways. I'm going to teach you the way I think is most effective for later math. Okay? So I'm going to say, let's take the natural log of both sides. Okay, but keep in mind, when I say the natural log, it doesn't have to be natural log. That's just what we're choosing to do. Okay, we are going to take the natural log of both sides, and then letter C is basically to then solve for x. Okay, now these can be very basic or they can be very involved. So let's look at number 1. When I look at number 1, I need to decide, well, which method am I going to use? Can I get the same base or can I not get the same base? I have a 1/8 and a 4. Well, in this one, I think, can't we do it the method we did before? Can't we get the same base? In fact, is this the exact same one that we did? It is the same. So if I recognize that I can get the same base, then I could just use the method that we did back here for example 1, right? Get -5/3. Okay, but I just want to show you, what if I didn't recognize that I could get the same base? Right? What if I didn't notice that? And let's see if we can take it through this method and see if we actually get the same answer. Okay? So in this case, I would isolate the exponential term. Well, do you see that the 1/8 is what actually has an exponent? So that's my exponential term, and it's already by itself. All right, so the first step is already taken care of. Then it says to take the natural log of both sides. Okay, I just thought about something. Sorry, I had to kind of pause and think this through for a second. I hope you're not going to be mad at me. This is why you should actually watch the videos carefully and not try and fast forward. I want to change something. I want to go up to letter B, and I know I said take the natural log of both sides, and that is going to be what I'm going to lean towards. But when I say take the log of both sides, I'm just going to leave it generic for now. I'm not going to say natural log. I'm just going to leave it generic and say log. Take the log of both sides. And I think when I'm doing the problem, I'll decide which log I want to take. Okay, because when I look at number 1, if I wanted to take the log of both sides, the idea is, what is it that would get rid of the exponential form? Okay, so my thinking is, why don't we take the log of whatever that base is? So, like for example, if I had a 2 to the x, I would take log base 2 of that. If I had a 5 to the x, I would take log base 5 of that. Okay, so with that in mind, on this one, it's going to look weird because it's a fraction. So the base is 1/8, so I'm going to take log base 1/8 of both sides. So I'm going to say log base 1/8 of both sides. So of 1/8 to the x plus 1. And then I have to take log base 1/8 of the right side. So log base 1/8 of 4. Now I know that looks crazy and ugly, but it's all because I'm choosing to use a method that is not my first choice. I just want to show you that I'll get the same thing that I did last time. So you may or may not remember some of the shortcuts we talked about. We said, hey, if this base down here is the same as this base right here, we talked about how the shortcut is, it's kind of like they cancel and it just equals the exponent. So this left side just equals x plus 1. I want to make sure you understand what I'm talking about. If I had, let's say, log base 2 of 2 to the 5th, that whole thing would just equal 5. Because the 2 is the bases and they're the same and they cancel. So if you don't remember that shortcut, go back to, I want to say it was 8.3. I think it was section 8.3 where we talked about all those shortcuts. Okay, so in the problem I'm working out, on the left side I've got x plus 1. On the right side, I still have log base 1/8 of 4. Now, yeah, I could solve for x by subtracting 1, and I'll do that in a minute, but let's see if we can figure out this part. What does log of base 1/8 of 4 equal? Okay, so forget the x plus 1 over there. Let's say I'm just trying to figure out the right-hand side. Remember how we said a logarithm is an exponent, right? So if a logarithm is an exponent, this is saying, hey, 1/8 to what power, sorry, 1/8 to what exponent would equal 4? Well, in order to do that, wouldn't you have to think through the same base anyway? Wouldn't you say, oh, look, 1/8 is a 2 to the negative 3, and that's being raised to something, I'll just say to the a, right? And that's supposed to equal 2 squared. So according to what we did a few minutes ago, doesn't that mean that negative 3a would have to equal 2? Oh, so a equals 2 over negative 3. So if we're saying that this whole thing equals 2 over negative 3, then that means we're saying x plus 1 equals negative 2/3. Well, if I want to solve for x and I subtract my 1, wouldn't I get negative 2/3 minus 1? Wouldn't that be negative 5/3, which is what we got up here, right? But wasn't this one up here so much more straightforward? Wasn't this one up here more straightforward? I think it was. I mean, you might have been confused even going through this one. So the point I was trying to make there is, if you can get the same base, use that first method. Don't use this logarithm method. Okay, so now let's actually talk about, okay, well, what's the point of the logarithm method? When can I use it? When is it smart to use it? All right, well, look at example 2. On this one, so right now I have a base of e and I have a base of 4/5. Well, okay, they're not the same base. I mean, I can't get e to be the same as a 4 or a 5. So they're not the same base. There's no way I can use the same base method. So now that means the second step, I'm going to take the log of both sides. Well, what is the base of this exponential term? The base is e. So the log that I want to take of both sides is the log that has a base of e. Well, what log has a base of e? Isn't that natural log? Okay, so I'm going to take the natural log of both sides. So I'm going to say natural log of e to the x plus 1 equals natural log of 4/5, right? Whatever you do to one side, you have to do to the other side. Okay, here's another shortcut. Do you remember this one right here, this shortcut where we said, hey, if this base is the same as this base, then they cancel? Well, that's the same thing with natural log. Remember how natural log and e kind of cancel? So the shortcut on the left-hand side is to say, well, that whole thing just equals x plus 1. Again, if you don't remember those shortcuts, go back to 8.3. And that's supposed to equal natural log of 4/5. Now, you may be thinking, oh, I got to figure out what natural log of 4/5 is. No, you don't. Natural log of 4/5, there's no way to know what that equals, what it simplifies to be without using a calculator. So, and it's just a constant. I don't know what constant it is, but it's just a constant, so don't worry about it. So if I want to solve for x, I just need to subtract 1. So x equals whatever the natural log of 4/5 is, and I don't care to find out the decimal, and then I'm going to subtract 1. So even though it's ugly, I have solved for x. I've gotten x by itself. The one thing I want to show you is, notice it's not the natural log of 4/5 minus 1. No, it's not one natural log. It is the natural log of 4/5 separate and then subtract 1. All right, look at number 3. First step. What's the first step? Isolate the exponential term. So that means I need to isolate the exponential term. Well, the exponential part is this part. It is 5 to the 3x. That's the exponential term. So not only do I need to get rid of the 10, but I also need to get rid of the 2. All right, so to get rid of the 10, we're going to add. So I've got 2 times 5 to the 3x equals 14. Okay, I still need to get rid of the 2, so I'll divide. So 5 to the 3x equals 7. Okay, so I've gotten the exponential term by itself. And so next step, I need to take the log of both sides. Well, what is the base? The base is 5. So I'm going to take log base 5 of both sides. So I'm going to say log base 5 of 5 to the 3x equals log base 5 of 7. So I did log base 5 of both sides. Again, look what happens on the left side, right? You have the same base, and so they cancel. I mean, there's a point to this. That's why we chose that. So what I have is 3x equals whatever log base 5 of 7 is. Again, log base 5 of 7, the only way to simplify that is to put it in your calculator and get some decimal number. I don't care about doing that. I don't want this to be a calculator problem. So if I want to solve for x, I'll just divide by 3. So x is whatever log base 5 of 7 is, all divided by 3. Again, it's ugly. Don't care. I have solved for x. There's no x's on the right side. I'm done. All right, now number 4 is a little more involved. So looking at number 4, why do you think this one's a little bit more involved? Well, do you see that there's more than one exponential term? So I can't say isolate the exponential term. There are two of them. All right, so, and they're both isolated if you want to think about it. I have one exponential term on the left and one exponential term on the right. Okay, so in this case, um, I've already done step 1. It's isolated, and now I'm going to take the log of both sides. But if you go with what we were talking about before, how do I know what log to do to both sides? Should I do log base 7 because the left side has a base of 7, or should I do log base 3 because the right side has a base of 3? And the answer is it doesn't matter. So this is one where, I mean, if you want, you could do log base 7. If you want, you could do log base 3. Or if you want, you could just do natural log of both sides. It does not matter on this side, on this one, because I have two different bases. So let's say, okay, so we have to choose what base. I don't know. Maybe I'll use one that's there, just because maybe something will simplify. Which one you want? Oh, 7 you say? Great. We'll take 7. So we're going to do log base 7 of both sides. Keep in mind, you have to do the same base on both sides. You can't do log base 7 of one side and log base 3 of the other side. All right, so I'm going to do log base 7 of both sides. So log base 7 of 7 to the x minus 3 equals log base 7 of 3 to the 2x. Okay, so on the left-hand side, because we have the same bases, right, those will cancel. So on the left-hand side, all I have is x minus 3. But on the right-hand side, I can't cancel that 7 and 3. They're different bases. All right, but the problem is I can't solve this if I have an x up here in the exponent. So remember that log property that says, hey, if you want to, you can move your exponent down in front. We need to do that. We've got to get that x down in front. So I'm going to write the 2x down in front, and then I have log base 7 of 3. Now, I know this is strange looking to you, and this is where we tend to get people that think that they want to crawl under the table, but just kind of watch, because as we do a couple of these problems, you'll see the exact same pattern shows up. This is some high-level solving skills. So this log base 7 of 3 is just a number. I mean, for all I know, that whole thing equals 10. I mean, it doesn't, but it's just a number. So I have this big, ugly x term, and I have this big, ugly x term. Well, the only way to solve for x is to get the x's to the same side, right? I've got to get the x terms on the same side. So I think what I'll do is I'll move this entire thing, because this entire thing is an x term, over here with this x. So if I do that, here's the x that was already there. I'm going to subtract this whole big ugly mess from the right. So I'm going to say minus 2x log base 7 of 3. And because I'm trying to get the x's by themselves, that means this minus 3, which is not an x term, I want to move over to the right side. So I'll add it over here and just get positive 3. So I've gotten both of my x terms, one very ugly x term, on the left side. Now, this it looks strange, I know, but this is kind of like those formula problems that we did that had, like, 3 or 4 variables, and like maybe you had to solve for a, and in order to do that you might have had to get that a separated. So I'm going to go back to the question I always ask is, how can I get these x's separated from all of this? Well, what if we were to factor out an x? If I factor out an x, what am I going to have? I'm going to have 1 minus, well, if I factor the x out, don't I have 2 log base 7 of 3? And then on the right hand side I have 3. Alright, there it is. I'm golden, right? If I want to solve for x, shouldn't I just divide both sides by 1 minus 2 log base 7 of 3? Because that way they'll just cancel out. So I'm going to have x equals 3 over 1 minus 2 log base 7 of 3. Again, I know it's an ugly answer, but I have x by itself. On the other side, there are no x's, so I'm done. Okay, so when you look at the homework, you'll notice, let's see, there's 2 pages of the homework, but notice I've even separated the different types, right? For let's see, 1, 2, 3, 4, 5, 6, 7, and 8. Basically, it says, hey, think about the same base, right? So you're going to do that first method where you get the same base on both sides and then set your exponents equal to each other. And then when you get down here to the different base, so this is going to be like the last type we did, where you get the exponential part by itself and take the log of both sides, and then solve for x. So we have just 4 of those. But the good thing about these is they kind of go in order with the notes. So like number 2 is going to be very similar to number 2 from the notes. And number 3 is going to be very similar to number 3 from the notes. And we could say the same thing about number 4. So make sure when you submit your homework that you're also submitting the notes with it. So you're going to have a total of 4 pages that you're going to submit all in one. And the other thing is, keep in mind, because Miss McKinley and I are kind of doing submissions a little bit differently, so make sure that you submit on the correct link. Hers will say 8.5 McKinley, and mine will say 8.5 Napier. So please make sure you submit it on 8.5 Napier. All right, as always, once you've done these problems and you've checked your answers, on the answers I'm not going to have all of my work because I want to see your work. But if you run into problems and you get stuck, hey, let me know, ask me a question, text, email, whatever, and we can figure it out. All right, so good luck with that, and I'll see you next time.